The next stimulant that we will go over is caffeine. Caffeine is probably the most widely used drug, as we see it in many beverages, including the infamous coffee. Taking caffeine results in increased energy, and for some people, it can make them jittery. First, let's see how the biology of caffeine works. Caffeine works in a similar way to Adderall, meaning that it affects a neurotransmitter in the brain. But instead of dopamine, caffeine affects adenosine. Adenosine is the neurotransmitter that is responsible for making your body tired. Now, what adenosine moves through the vesicles in the cell and goes through exocytosis to be released in the synapses and attaches it to the receptors. But when caffeine is involved, caffeine binds to the receptors in place of adenosine, resulting in a fake energized feeling, as your body is not recognizing that it's tired. In order to understand how caffeine does this, we must first look at the chemical structures of both adenosine and caffeine. Looking at the chemical structures, we can see that both adenosine and caffeine have two semi-carbon rings along with nitrogen. This is probably what fakes out the adenosine receptors and binds them to caffeine. Now, let's look at addiction. What happens when a person becomes addicted to caffeine is their body naturally increases the amount of adenosine receptors in their neurons. This is what leads to dreaded caffeine withdrawal, increasing in tiredness, and those awful caffeine deficiency headaches. However, although caffeine can cause addiction, and addiction generally has a bad connotation, caffeine itself can actually do some good to your body. It can increase your metabolism, increase your mental and cognitive abilities, and lighten your mood. Now that we know how caffeine biologically works and have a basic understanding of how things work on a molecular, atomic, and subatomic level, let's look at the chemical processes of addiction and possible areas to look into if you wanted to ease withdrawal. As of now, there is little research on why more adenosine receptors pop up on neurons. However, it is known that receptors are proteins that neurotransmitters are able to bind to and open up to stop or induce the flow of ions. So, would more adenosine work to ease withdrawal? Well, let's think about that. Adenosine makes people tired, so more adenosine would just make people more tired, and so they would want caffeine. Would less adenosine work? Theoretically, maybe. So let's look into how adenosine is made. Adenosine is created out of AMP. The body does this by using the enzyme ecto-5 nucleotidase to make adenosine. First, let's look at reactants and products. Reactants are the substance that we're starting with, and products are the substance that we end with. The reactants and products for this chemical equation is 10 carbons, 14 hydrogens, 5 nitrogens, 7 oxygens, and 1 phosphorus, which is AMP, plus an enzyme, and it makes the products of 10 carbons, 13 hydrogens, 5 nitrogens, 4 oxygens, plus the enzyme, which that chemical formula is also known as adenosine. But wait, this chemical formula isn't complete. Something's missing. This chemical equation isn't balanced, meaning that there's something being left out, because what we start with is not, the atoms that we start with is not all that of the atoms that we end with. Well, what's missing? If we do the subtraction, we are left with 1 hydrogen, 3 oxygen, and 1 phosphorus. So, how do we know what these atoms will form into? Well, atoms want to go to the lowest energy state possible. This means that the phosphorus will double bond with the oxygen and will bond with 2 other oxygens, and that will leave them negatively charged, and it will also bond with the hydrogen. This will form an hydrogen phosphide ion. So, what would this whole equation look like? Well, it would look like AMP plus the enzyme equals adenosine plus hydrogen phosphide plus the enzyme. The next question to ask is, what type of reaction is this? Well, in order to figure this out, we have to choose out of 5 types of reactions. The first type of reaction is decomposition. In this reaction, 1 molecule is being formed into 2. The next is synthesis reaction. In this reaction, 2 molecules are being formed into 1. Then comes single displacement reactions. In this, one of the atoms is being replaced with another. Then comes double displacement reactions. In this reaction, 2 of the atoms are being replaced. Finally is combustion reactions. In this reaction, a substance with oxygen is being turned into a molecule and it releases heat. So, let's look at our reaction. If we cut out the enzymes, it's just a facilitator after all, we get AMP equals adenosine plus hydrogen phosphide. So, 1 molecule is being turned into 2. If we remember our 5 types of reactions, this is a decomposition reaction. So that's it. If we just get rid of a lot of AMP, we can stop the production of adenosine. But wait, where does AMP come from? Well, AMP is formed from ADP, which in turn is formed from ATP. And if we remember from biology, ATP is the energy currency of the cell. So, in order to stop the breakdown of ATP, which in turn stops the breakdown of ADP, which in turn stops the formation of AMP, which would then stop adenosine, you would have to basically stop using energy or stop moving, which wouldn't work for a variety of reasons. So, as far as high school chemistry goes, there's no way to ease the withdrawal by altering the amount of adenosine produced in the brain. So, your best choice if you want to get rid of the caffeine in your system is probably easing off of it, which will be slightly painful, but not nearly as painful as the withdrawal from other drugs. But more research needs to be conducted on adenosine, as possibly some way we could ease withdrawal by looking into adenosine and how it works.